Our first slide is really to look at circles and the fact that they're found in nature, from the simple raindrop falling on the river or the pond or the puddle, to there's plenty of that around at the moment, to spectacular sites like a double rainbow at one of my favourite sites in the Pembrokeshire National Park, Lecca, big slab on a tripod in Welsh, very colourful language, and there's the double rainbow, and that's an arc of a circle. There are built circles, of course, in our environment, and there are sky circles and living circles. We see the disk of the sun and the moon, and we see it, the sunflower, which obviously is part of that. We saw the picture of Mary surrounded by that in Bert's talk, and there's the transit of Venus just happening there across the surface of the sun, because I still do that sort of mad thing. It's only once in my lifetime, twice in my lifetime, that I'm ever going to see that. And I got the first one in 2004. There's the disk of the sun, and there's the planet Venus. You see how small it is, and how small we must be, how little we are in the immensity of space. And there's a nice built circle, or an arc of a circle. There we are. And there's some lovely circles there, about which there's been a lot of controversy. That's sort of the power point of London, isn't it? Battersea Power Station. And then we've got prehistoric built circles with savages. And there they all are. And mysteriously, these stones have materialized overnight. And busty tailors on an eagle overhead. And they're trying to think that they couldn't do it. So it's impossible. But there's a nice henge with a double ditch and so on. So it all leads us to the fact that human cognizance of the relationship between the perimeter or circumference of a circle and its radius or diameter. And whether you use the modern way of using the diameter as the constant or pi, the traditional one, it's really not that big a deal because you can do either, and I can be flexible enough. So, but the two formula that we learn at school are 2 times pi times the radius gives us the circumference, or twice the diameter times pi is the circumference, and pi times the radius squared equals the area. Now, there are several constants found throughout history used to simulate convenient values of pi are 22/7, which you use at school. In the days before electronic calculators, these were very important for, should we say, less than 100% precise. They're not bad. You can't do many things in life to 99.96%. I certainly can't even get Rice Krispies into my mouth with that precision. And the most accurate, I don't know, I don't eat Rice Krispies. I don't know why I said that. It's absolutely awful food, but it is awful. It is difficult to get in your mouth. All right, that's why I said it. It's not like our local whole food muesli, which is difficult to get out of the packet. The most accurate one we know is this one, 355 divided by 113, and that's almost spot on. I mean, there are so many noughts there as to make it indistinguishable in any practical engineering project, I would have thought. And the historically used value is this lovely 864/275, which is the one that you find in the Egyptian monuments again, and quite a few times there's a rough approximation there. So there's pi. I don't want to do this a maths lesson. This is the end of the talk. I can't do Bert, but you're not following me fast enough. You manage with Bert, you can do it for me. You were asleep. You want to see a crop circle being laid? Right. Guess what? It's Bert. So, and it was a great lecture. I'm not mocking. That was a fantastic choreography. So, sooner or later, people appear to have got the message that there was this relationship, and the sky was also informing people of geometry, whether they liked it or not. As soon as they started monitoring where Venus stopped in the sky, which it does every 1.6 years, they would notice an 8-year sequence and 5 stops. And there it is from the year 1990 to 1990 something or other, 98. And it stops at these 4 points, and each time you can draw the pentagon, the little arrows there show where it stops the next time. So it actually can be drawn in one single stroke of the pen. So there's the Earth. We've drawn it in the middle because it appears like the Earth's in the middle. I don't have a problem with that either. But modern astronomers really do have a problem with putting the Earth at the middle because they think naively that we don't realize where the Earth is. But, you know, if you're on a railway train measuring the velocity of another vehicle next to you, you don't pretend the railway train's not in the middle of things. It's where you take your measurement from. You'd get very badly injured if you did. So there's the Venus pentagon, and it's, of course, loaded with other constants like phi, which we don't need to cover. But what I want to say to you, first of all, a central theme of this lecture is that time and space are involved in this process. It's no longer about just space. You have to wait the 8 years, and you have to remember which star Venus stopped next to in order to record over 8 years. It requires a certain level of consciousness and measurement and observational accuracy in order to define this. It is a pretty accurate pentagram. It only moves 2 degrees at the end of the cycle, so it takes sort of 1,000 years to rotate slowly around the sky. But there it is, the Venus pentagram. Those of you who were up during the fine weather in the spring, when the weather was looking like it was going to be nice in the summer, will remember that Venus, for night after night after night, was gradually slowing down in March and April, a wonderful spectacle. Every month the moon was going past it, and you were getting a free Muslim flag in the sky and things like that. It was a very good time. That was one of these points. And so the discovery of astronomical geometry and meteorological geometry and a geometrical framework coming from the cosmos, we can imagine must have appeared wonderful. It must have appeared like there was some mystical or numinous force, called God in my language, we don't need to give it another name really, that was responsible for order in the cosmos rather than the chaos that everybody is so scared about. Even today, we don't like chaos, do we? Anarchy, chaos, we don't do it. It only lasts, it brings change, but it's basically a very uncomfortable thing. We like security, we like to see these patterns. They tell us that things are going to continue. And there's another one from Babylon. This is a really cool bit of stuff that survived all those years and is in our culture today. There's the moon there. It's the fastest moving object in the sky. From night to night it moves. I keep saying guess what like Burton, I must stop doing that. Guess what? It moves 13 degrees, as you might expect the lady to move. And therefore it's a very fast moving. Mercury can make up to 2.5 degrees in a day, but it follows the sun. It's always near the sun. So its average is at 1, but when it's really going for it, Mercury, it fair shifts for night for night against the stars. Venus is a bit slower, but that's our third fastest. The sun moves 1 degree a day, which is where the word degree comes from. Mars is quite slow. It takes 4 days to move a degree. And Jupiter takes 12 years to go around the cosmos, so it's even slower. And finally, we've got Saturn, which takes 29.4 years to go around the cosmos. So there's the planets represented in order on a heptagon of their speed. Now, so what, you might say? What's that got to do with that? Well, first of all, why would you choose a heptagon? Well, the answer is that throughout history, we've always had a 7-day week. And 7 is a very big number in many religions, the Jewish religion particularly. And we've chosen, even in our modern calendar, to try and stuff a 7-day week into a year that doesn't divide by 7. There are bigger problems, like we have a square calendar for a circular process, which is also bonkers. And we could change this. When we look in the mirror and say we are divine beings and we could change everything, but we don't, which has been said by 2 speakers, we could actually rip up the square calendar and start to think about designing a good circular one. There are such things available, I know. So what's this got to do with the days of the week? Well, the answer is that if you start with Monday, and you make a heptagram, you go from Monday and you go to Mars, which is Tuesday, and then you go to Mercury, which is Wednesday, mercredi, and then you go to Thor, which is Thursday, or Jupiter's day, and then you go to Dydd Gwen in Welsh, which is Friday, which is Freya, and then Saturday is Saturn, which is Saturn day, and then you've got Sunday and back to Monday. And you create then a heptagon star in the order of the days of the week. Now, this is mainstream. I mean, any historian will avoid it, maybe, in a university education, but this is well known. It's called the Chaldean order. But the point is the creation myth in our Bible, and the Western Bible, which is poached from the Babylonians, is about the order of creation.